Good afternoon, students. In the last class, again, I did so 40 minutes of class, but it is uploaded only 8 minutes. But no problem. I'll go with the same topic today. Okay, I'll continue with the same topic. Listen, students, you already learned about the adjectives of this metallurgy. Okay, so in that, the first one is the techniques involved in metallurgy. In that, before going to that, I'll explain some of the terms which we are often used in this metallurgy topic. Okay, so in that, first one is mineral. Okay, so mineral means, listen, it is a chemical substance. It is a chemical substance which is available from available at earth crust obtained by mining. Okay, student, the first thing we often used is mineral. So mineral is a chemical substance which is available at earth crust obtained by mining. So we know very well about mines. Gold mine is there, iron mine is there. So we are doing mining purpose at different places with a different metal recordings. Okay, so that is minerals. They are available from the earth crust. Okay, by digging the earth crust we can get the minerals. So next one is ore. Okay, so ore means it is a mineral. It is a mineral, but not but it is a mineral which is used to extract metal. It is a mineral which is used to extract metal. Okay, so many minerals are there. In that, we will choose one type of mineral which consists of more number of more percent of metal in that, and also which costs very less for the extraction of the metal. So that type of mineral is called as ore. So one thing I told, all ores are minerals, but all minerals are not ores. This is the one thing to remember. Ores are minerals, but all minerals are not ores. Okay. Next, third one is gangue. Okay, what is meant by gangue means the unwanted impurities present in an ore. The unwanted impurities present in an ore is called as gangue. That may be sand, mud, stone, or any other metals, etc. Okay, so this is called gangue. The unwanted impurities which is present along with the metals in the ore, that is called as gangue particles. Okay, the gangue particles may be sand, mud, stone, because after consists of these things also. Along with that, in the ore, that metal also present. Okay, while we do mining means, and along with the metal ore, we'll get these things. These are called as gangue particles. Okay, next one is flux or slag. Okay, this flux and slag is also a same thing. The unwanted impurities which is extracted or generated during chemical process. Okay, this is also the GAN particle obtained or formed during chemical process. During chemical process. So this is called as flux or slag. So one best example is, listen, silica, that is sand, is one of the impurity which is present in the ore. Okay, to that if we add CaO, lime, then it converts to what? CaSiO3, calcium silicate. This is called as what? Slag or a flux, chemical compound, that is. Okay, so during the extraction of the metal, if we are doing again the concentration of ore, means removal of unwanted impurities by chemical process. If small amount of any silica is present, SiO2 present, by adding CaO, we can remove that as a calcium silicate. Okay, it is a hard substance, it is easily removed by the ore part. Okay, so these are the terms used in metallurgy: mineral, ore, GAN, flux. Okay, so listen, I told you all ores are minerals, but all minerals are not ores. So for that, one example is, listen, iron is there. Iron has four types of ores. One is hematite, hematite. Second, magnetite. Okay. Third, siderite. Fourth, iron pyrite. Okay, students. In this, all these four are minerals of. Okay, all these four are minerals of what? Iron. Okay, hematite is also there, magnetite is also there, siderite is also there, and iron pyrite is also there. But here what happens? Here only hematite is used to extract iron. Okay, so in the this sentence obeys this example. Okay, listen, all ores are minerals. So hematite is a ore we use to extract iron, so it is a mineral. But all minerals are not ore. All these four are minerals, but among these four we didn't use these three minerals to extract iron. Okay, why we didn't use these three? Why only we choose hematite means I'll explain now why. Okay. So listen, students, four ores of iron is there. One is hematite, correct? Next, magnetite. Next, iron pyrite. Next, siderite. Okay, these are all the four ores of iron. Okay, so why we choose hematite as a ore of iron? Why not these three means? Listen, if we check the cost of production or cost of extraction of this iron, so listen, assume iron cost 30 kg, 30 rupees per kg. Iron cost is 30 rupees per kg. So listen, the cost of production of 1 kg of iron from this magnetite ore cost 80 rupees. Okay, this one cost 40 rupees. This one cost 20 rupees. Okay, this one cost 5 rupees. Assume, okay, I am not exactly telling that oh, this much only the cost of production is. Just I am explaining why they choose this ore as a this mineral as a ore of iron. Okay, listen. Here, iron cost 30 rupees per kg. So here, per kg of iron to be extracted from these both cost different prices. So here what happens? The cost price of iron 1 kg is 30 rupees. The production cost is 80 rupees. Means it is in a loss. Okay, here also same thing. Here also same thing. But here listen, we will get 10 rupees profit from this ore, sorry, this mineral, and 25 rupees profit from this mineral. Okay, so by seeing the convenient of the cost of production and the cost of extraction of the metal, we choose which metal is better to extract the which mineral is better to extract the suitable metal with lower cost. Okay, so among these three, you can easily came to know why the hematite is chosen for as a ore of iron. Okay, so this is the way. Okay, next one is the techniques involved in techniques involved in metallurgy. Okay, so listen. The techniques involved in metallurgy. It involves three techniques. In that first one, concentration of ore. In that first one, concentration of ore. Second, isolation of metal. Okay. Third, refining of the metal. Okay. So listen students, in the metallurgy, the techniques involved in the extraction of the metal from the ore is first concentration of ore, next isolation of metal and refining of the metal. So in this concentration of ore, so concentration is also called as dressing of ore or beneficiation of ore. Dressing of ore or beneficiation of ore. Okay. So here in the concentration of ore means it is the removal of impurities, that is gam particles. It may be a sand, stone, or some other extra elements which we did not require in the extraction of the metal. So those unwanted impurities can be removed from the ore particle, that is called as concentration of ore. Okay, so in this concentration of ore, it has further 4 types. Okay, so first one is hydraulic washing. Okay, so hydraulic washing. First one. Second is magnetic separation. Hydraulic washing, magnetic separation. And let me clear here. Hydraulic washing. Okay. Next, magnetic separation. Okay. Third one, growth, rotation. Okay, and the last one is leaching. Last one is leaching. Okay, so this is the four different techniques used to concentrate the ore. Okay, next one is isolation of metal. Isolate means, nowadays you often listen the word isolation, isolation, isolation because of corona, right? The isolate means separate from. So isolation of metal from separation of the metal from the concentrated ore. I told you in the concentrated ore only some part of the impurities can be removed. Okay, so not completely. So here by the removal of only metal from the ore particle, that is called as isolation of metal. Okay, this isolation involves conversion of ores to oxide. Conversion of ores to oxide. Second one is electrolysis. Second one is electrolysis. And third one is oxidation and reduction. Oxidation and reduction. Okay. So last one is refining. Once the metal is isolated from the isolation techniques by using these three methods, then it is subjected to refining. So refining techniques involves distillation. Okay. Second, liquefaction. Distillation, liquefaction. Third, vapor phase refining. Fourth, zone refining. Okay. Next, electrolytic refining. Last one is chromatographic refining. So these are all the refining methods. Okay. So listen, if we want to extract a metal from the minerals, we have to follow these three methods. So concentration of the ore, the concentration of the ore have these four techniques. Among four, any one technique is used to concentrate the ore. Again, the concentrated ore, the isolation of metal takes place. Means the concentrated ore is subjected to any of these three techniques. Then the metal is separated from a concentrated ore. Once the metal is separated from using these techniques, then it is subjected to what? A refining technique. Once it is refined, then we will get a crude metal, that is approximately above 90% pure metal. Okay, after that, once we get the pure metal, it is used to prepare a different utensils. For aluminium, if we take this, we use aluminium for a cooking purpose. Cooking utensils are there. For iron, we used to prepare a bit used as a building material. Okay, construction material will be used as a bench. Okay, for different purpose, once the metal is extracted, it is used to prepare other useful products. Okay, this is all about the technique, students. Next one is some important ores of the metals. Okay, so this one is very important for 1 mark. As I told you yesterday's class, so this chapter is for 4 marks, 1 marks, 1 question, and 3 marks, 1 question. That is question number 19. Okay, question number 19 is for 3 marks, which is from this chapter, and the 1 marks, 1 question that may be varies. Okay, next one is important minerals of some metals. Important minerals of some metals. Okay, the first one is aluminium. Aluminium has bauxite and colonite as a minerals. So in earth crust we get bauxite and colonite, the ores are aluminium. What is the composition of bauxite means? Al, OX, OH, 3 minus 2x. Okay, in the simple thing we consider bauxite as Al2O3. Okay, next. So listen, next one is colonite. That is AlOH 4 times into Si2O3. This is the composition of colonite. Okay. Next one is iron. I told you iron has 4 different minerals. First one is hematite. Next, magnetite. Next, satellite. Next, iron pyrite. Okay, so hematite, the composition is Fe2O3. Magnetite, Fe3O4. Okay, then satellite, Fe2CO7. FeCO3. Okay, iron pyrite, Fe(S2). Okay, so this is the ora, hematite, magnetite, silver, iron, pyrite. So next one is copper. So copper as the fourth, copper pyrite. Okay, malachite, cuprite, and copper glans. Okay, so copper pyrite composition is Fe(S2). You may also write CuS and FeS. CuS and FeS are CuFeS2. Okay, next malachite. That is CuCO3 and CuOH. CuCO3 into CuOH. Cuprite means Cu2. Yes. This one Cu2O. Okay, student. So this is Cu2O. This is Cu2. Yes. Next, zinc. That is zinc blend, calamine. Next, zincite. Okay, zinc blend means 7s, calamine means 7CO3, zincite means 7. Okay, so listen students, here what I am going to tell is all the minerals are in the oxide form, are in the carbonate form, are in the sulfide. So in the earth crust, no one element, not no one, some element will exist in a free state, like carbon is there, coke is there, gold is there. Okay, that gold, carbon and coke, they are occur in a free state. There is no any other impurities are present inside the ore particles. Okay, so only the pure metal existing free state are carbon and gold, only few metals. Okay, except them all are occur in the form of ores and the minerals. Okay, so these minerals are of oxides, carbonates, and sulfates because only the oxides, sulfate, and carbonates are stable in the universe. Okay, only these type of minerals can occur in the earth crust. Listen, so this table is very important. Then I ask the question. I told you here 1 mark question will arise from this chapter. So that maybe arises from this table. Okay, then I ask, write the sulfide ore of iron, write the sulfide ore of copper, write the sulfide ore of zinc, or oxide ore, or a carbonate ore. Or then I also ask, what is the composition of copper pyrite? What is the composition of iron pyrite? What is the composition of cuprite? Like that, then I ask. Give an example of a sulfide ore of copper, zinc, or iron, or a carbonate ore of respective metal. Like that, then I ask. Or then I directly ask by giving the mineral name, the composition of the mineral. Okay, this is very important, students, to note on the table and keep on practicing. Okay, there may be a chance of arising a 1 mark question from this table. Okay, so next one we will discuss about the extraction techniques of metal in metallurgy one by one. Students, I told you the first technique in metallurgy is the concentration of ore. Concentration of ore. Okay, what is the concentration of ore means? The process of removal of unwanted impurities from the mineral or a ore. Okay, just ore. The process of removal of unwanted impurities from the ore is called as concentration of ore. And I told you this is also called as dressing of ore or beneficiation. Dressing of ore or beneficiation. Okay, so this is a concentration of ore, the removal of unwanted impurities from the ore. So in that I told you 4 different techniques are there. First one is hydraulic washing, second one is magnetic separation, third one is float flotation, and last one is leaching. Okay, so in that first one is hydraulic washing. Hydraulic washing. So I write here. Hydraulic washing. Okay. So listen, students. I'll write diagram here. This is a type of arrangement. Okay. Next. hydraulic washing technique arrangement. So students, here this is the powdered ore. Powdered ore, which consists of gangue particle as well as ore particle, that is metal. Ore particle means which consists of a metal. So here what happens? The red ones, these are ore particles. Okay, this black color are gangue particles. Okay, so here what happens when the powdered ore is subjected to a stream of water or upstream water. So water is flow in this manner upstream. Okay, here in this manner. Okay, then what happens? So listen, this is also called as gravity separation method. Gravity separation method. It is also called as hydraulic washing as well as gravity separation. Why? Because listen, because of the change in gravity of ore particle and gangue particle, this separation method takes place. Okay, so here what happens? Ore particles are having high gravity than this gangue particles. So then when upstream water, a stream of water which is upstream, okay, passed, is applied here, a stream of water is passed here, the powdered ore is subjected to that stream of water, then heavy gravity molecules or high gravity molecules or particles are collected here. Okay, and the lighter gravity, that is gangue particles, are moved with the stream of water. So here the stream of water is collected, all the gangue particles are removed, which are very having less gravity. Okay, so this is hydraulic washing, means washing using water. That's why this is called as hydraulic washing. It is also called as gravity separation because this separation techniques takes place or works on the basis of different gravities of the difference between the gravities of the ore and the gangue particle. Here ore particles are having high gravity compared to the gangue particle. So to that, they didn't ask any diagram in the examination. This is important for 2 marks. All the 4 techniques are important for 2 and 3 marks. So they ask what is the principle of hydraulic washing? What is the process? Okay. So principle is this technique of separation takes place based on the difference between gravity of the gangue and ore particle. So listen, this principle is very important. This principle is not given in NCERT textbook. They simply explain. This is also called as gravity separation. So this type of techniques in diagram also not there in NCERT. So this is the process which follows the hydraulic washing. That is the arrangement. Okay. So here this is the principle. When the powdered ore is subjected to an upstream water, then the high gravity ore particles are collected in the lower medium, and also the lighter gravity particles, which are gangue particles, are carried to the water. Okay, then it can be easily separated by this technique, and this is the principle. This techniques of separation takes place based on the difference between gravity of the gangue and the ore particle. Okay, so you write this thing in the notebook clearly because this is very important for 2 marks and must and should for 1 mark. 1 mark question I told you, them as the composition of force or them as principle of any one of these techniques. Okay, so next one is Second one, the magnetic separation. Second one is B, magnetic separation. Okay, so in this magnetic separation, so listen, I'll do first arrangement. So listen, this is a magnetic rollers. Okay, these are magnetic roller, and this is a conveyor belt. It is like a device used in machine, grinding machine, you know. Team we are calling. Okay, so this is the conveyor belt. Okay, conveyor. This one is magnetic. Okay, rollers. Conveyor belt and the magnetic rollers. They rotate in this direction like this. Okay, that is clockwise, sorry, anti-clockwise direction. Next. Here, what is there? Gas particle also there. They are carried out here. Okay, so listen students, what happens when this powder ore or a mineral is carried through this conveyor belt around this magnetic rollers. So then what happens? Here two containers will be there, which is very near to the magnetic rollers, which are far away from the magnetic rollers. So then what happens? So you know that consider iron ores here. That's why I am writing in green color. The basic color of iron is green. Okay. So next, this one is the gas particles. Move from here and collected here. Okay. If we consider, listen, that depends upon the magnetic property of the gangue and the ore particle. But here I am considering iron ore. Assume hematite ore. So in that iron ore, iron, you know, iron is the very good metal which attract the magnetic property. It is having highly very magnetic in nature because you know it has 4 unpaired electrons in its original atomic state only. So it is strongly attracted by the magnetic field. Iron and magnet combination we know already. Okay, so that's why I am considering iron ore. Iron ore, that is iron ore particle, is attracted by the magnetic field. So they are attracted by. Okay, the gangue particles is somewhat repelled by the magnetic field. They didn't have that much of attraction, so they are falls away from the magnetic rollers. So this is the technique used to know the impurities in the ores having different magnetic properties. So the principle involved here is this technique of separation takes place due to the difference in magnetic properties of ore and gangue particle. So this is the principle of this magnetic separation. So here what happens? The powdered ore, which consists of a gangue and a ore particle, is subjected or carried by a conveyor belt around this magnetic rollers. These magnetic rollers, that is ore particle, we are considering iron ore here. They are attracted by the magnetic field. They are collected near the they falls near the magnetic roller. And these gangue particles, they are repelled by the magnetic field or less attracted by the magnetic field. So that's why they fall somewhat away from the magnetic roller. So we can easily separate these impurities from this type of ore particles. Okay, so this is the principle. This technique of separation takes place due to the difference in magnetic properties of ore and gangue particle. Either ore may attracted by the magnetic particle or gangue may attracted by the magnetic particle. Okay, students. So this is all about the separation techniques of concentration of ores. In the two techniques I explained. So tomorrow's class I'll explain two more techniques. Okay, thank you. Note down this. This is very important for 2 marks. This principle is important.